Okay, today we are going to start our new session on buoyancy and flotation. Okay, basically here we are going to talk on we are consider mainly focus on Archimedes principle, buoyancy or Udukur, and this is the Tamil word. Okay, what is buoyancy or buoyant force? Now you think, now if you put a ball on a fluid, you can see some force apply by fluid on the fluid on the object, upward force. Okay, because of that the ball cannot immerse. Okay, that means ball floats on the fluid. But if you think in air, ball can move one place to another place without any problem. But if you think about the water or when any inside any fluid, ball cannot go inside a fluid because of this buoyancy or buoyant force. Okay, the buoyant or buoyant force, buoyancy, when a body is immersed wholly or partly in fluid, an upward force is exerted by the fluid on the body. This upward force is equal to the weight of the fluid displaced by the body. This upward force is called as buoyancy or buoyant force. Okay. Now think, now there is a object. Okay. If it is plot, okay, if it is plot, now you can see this is the underwater. Sorry, this is very difficult. Okay. This is the underwater volume. Okay, according to definition of the buoyancy, this underwater displaced water liquid weight should be equal to the buoyancy force. Here also, now the buoyancy force is equal to the weight of displaced water by object. Okay, doesn't matter it sink or float. Okay, now what causes buoyant force? Okay, buoyant force is the force on an object exerted by the surround fluid. Okay, when an object pushes water, the water pushes back with much as it can. Okay, here to get some idea on the buoyancy force, you can see this is board, this is a steel. Okay, now if water can push back as hard, okay, if water can carry the weight of the object, then object will float. Object will float on the water. Otherwise, object will sink like steel. Clear? වතුරට මෙයාගේ බර දරා ගන්න පුළුවන් නම් ඒක පා වෙනවා. එහෙම නැත්නම් පල්ලෙහාට යනවා. If object floats, then we can say buoyancy force should be equal to the weight of the object. Because of the equilibrium, we can say now here, when you consider the force acting on the object, there are two forces only. That means weight and the buoyancy force. For floating object, the buoyancy force is equal to weight. But this is not the floating object. This is the sink. Now it still sinks inside water. Now here, when you consider the equilibrium, now there are two forces as you see. What is the buoyancy force, buoyant force, and weight? But when you consider that all force, there should be another force here. What is that? It is the normal force acting by the flow. There is a normal force. Then by consider the equilibrium, you can say normal force by buoyant force should be equal to weight. Make equilibrium ගැන කතා කරොත් දරුවෝ මෙතන බල තුනක් ක්‍රියා කරනවා. මොනවාද? මෙතන පුෂ්ණයෙන් ඇති කරන අබිලම් ප්‍රතික්‍රියාව, ඊට පස්සේ buoyant force එක, ඊට පස්සේ බර. එතකොට මේ උඩුකුරුතෙරපුමයි මේ buoyant force එකයි normal force එකයි සමාන වෙන්න ඕනේ weight. Then okay, that means the floating object, we can say buoyant force is equal weight. Otherwise, buoyant force is not equal weight, but always buoyant force is equal to the weight of the fluid displaced by the object. Okay, that is the main theory. But by considering the equilibrium, we can define another we can consider we can define another equation. Okay, now how do you calculate FB? FB means buoyant force. Okay, by using Archimedes law. When an object immersed wholly or partially in a body, in a fluid, buoyant force is equal to the weight of fluid displaced by the body. Okay, consider density of the fluid is rho, and the displaced water liquid volume is V. If displaced liquid volume is rho V, now you know how. Now here FB equal what? Weight of displaced fluid. How do you calculate weight? We can calculate weight. Sorry. This one. Okay. Here we can calculate if the M displays water weight of the displaced water is liquid is M, then we can find the weight of the displaced water. What is it? Is mg. හරි නේද? අපි මේක විස්ථාපිත තරල බර කියන්නේ කොහොමද? mg. But you know rho. What is rho? Density. Density can be divided as what? Density can define as M over V. Using this equation, you can find M is equal V rho. Then we can substitute V rho here. Then we can find this equation. Clear? Okay. This equation come, okay, using Mg. M is equal weight displaced water volume, liquid volume. Rho is the volume of the fluid. Then this is the M. This is the G. Okay. Now, if buoyancy flows, weight of displaced fluid. Now, if object floats on the object, then we can say buoyancy force is equal to the weight of the body. Otherwise, if object sinks, then we cannot take this equation. Okay, then we cannot take buoyancy force is equal to weight of the object. There are another force here. Okay, we will consider it with some example. But if object doesn't float on the fluid, then we cannot take this consideration. Okay, object එක පාවෙන්නේ නැත්තම් මේක ගන්න බෑ. පාවෙනවා නම් එකේ තියෙන force දෙකයිනේ, බරයි buoyancy force එකයි විතරයිනේ. එහෙනම් buoyant force එක සමාන weight of the body කියලා ගන්න පුළුවන්. Okay, now using this equation, now for floating object FB equal V rho G, FB equal mg, then we can say V rho G equal mg. We can use this equation to calculate FB, that means buoyant force for floating object, not other object. Okay, now center of buoyancy. Now you think there's object like this. Okay, now there's object like this. Okay, now this is the object. It immersed it immerses. Okay, now think this is the body ball. Okay, and the volume of the ball is V. This immersed volume of the ball is V bar. Okay, V bar. Now you can find the density of center of gravity of this displaced water volume. Okay, you can take this part. Okay, you can take this part. Think now you are going to take this part. Okay, I will cut this part. Okay, now this is the immersed part. Now you can find the density center of gravity of this part. You think this is the water, shape of water. Now you can find the some point as the center of gravity of this displaced water. මෙන්න මෙතනින් විස්ථාපිත තරල කෑල්ලේ මෙයා හැඩේ අපිට center of gravity හොයාගන්න පුළුවන්. That is called as a center of buoyancy. The point through which the force of buoyancy is supposed to act as is known as the center of buoyancy. ඒක හරියට මේ වෘත්ත කේන්ද්‍රය වගේ තමයි. Okay, as the force of buoyancy is a vertical force and is equal to the weight of the fluid displaced by the fluid, the center of buoyancy will be the center of gravity. Okay, there is some problem in this definition. Okay, doesn't matter. We will take this example. Okay. The center of the buoyancy will be the center of gravity of the fluid displaced. Okay, displaced water volume. Okay, that's all. Then this is the displaced water, underwater volume, under fluid volume, anything. Okay, now the buoyancy center of gravity of this underwater volume is this one. That's called as a buoyancy, center of buoyancy. Meta center. Okay, now you think now there's a floating object like this. Okay, now if you give small rotation, a small angle, then the object it starts to oscillate about some axis. Okay, about some axis. Okay, now here you can see then this object is oscillating about this point. Okay, in my example then this is called as meta center, the point which oscillates about the point when we give a small angle or displacement on a body. Okay, in floating object, not the sinking object. Okay, in floating object, if we give a small displacement, then object starts to oscillate about some axis. That point is called as a meta center. Okay, this is very important. Based on the meta center, we can define the stability of a body. Okay, මේ meta center එක කියන්නේ මොකක් හරි object එකක් තිබ්බොත් අපි මෙහෙම object එකක් තිබ්බොත් අපි මේකට පොඩි displacement එකක් දුන්නොත් මේක ඔහොම මේක මොකක් හරි point එකක් වටා මෙහෙම ඔහොම oscillate වෙනවා කියන්නේ ඔහොම දෙපැත්තට යනවා. Okay, that point called as it may be above the object, inside the object, or this is the buoyancy, this is the gravity, or be in between the GB. Okay, it may be anywhere based on the point of meta center point. We can define the stability of the given object. Now this is the GB. Now about this axis the object rotates or oscillate, not the rotate, oscillate. Okay, now this is the point buoyancy force which upward force act. This is the point which weight is act, weight act. Okay, let the bodies okay, now you think let the body be tilt, okay, slightly, or it undergoes a small angular displacement theta. It is assumed that the position of the center of gravity G remains unchanged related to the body. Okay, now you think, now if you think a ship, in the ship there are some containers and other things. While oscillating, the object may be displaced. Okay, then the weight density, center of the density may be changed, but here we think this G doesn't change, okay, related to the body. ඒ කියන්නේ දැන් මෙහෙම ඔසිලේට් වෙනකොට සාමාන්‍යයෙන් ඔබ්ජෙක්ට් එහෙට මෙහෙට යනවා. එතකොට G වෙනස් වෙන්න පුළුවන්. අපි මේකෙදි හිතනවා එහෙම G වෙනස් වෙන්නේ නැහැ කියලා. Okay, the center of B however does not remain fixed related to the body. Okay, while you think while rotating, okay, while rotating, now this is the displaced water volume. Now here this is the displaced water. Okay, now when it rotates, you can see, yeah, you can see this is the displaced water. Now it is not equal to this point, and the buoyancy force is act here. You can see act here. Now while oscillating on this one, buoyancy point move down right side. Okay, when object rotates or oscillate, or when we give the small displacement about some axis in right side direction, okay, left side, the right side direction, buoyancy force moves to right side. Then what happens? Because of this force, object tends to move other side, then left side. Okay, then ඔයාලට පේනවා ඇති මේකේ buoyancy force එක මෙතන ඉඳන් මේක දකුණට ගමන් කිරීමක් වෙලා තියෙනවා. ඒ කියන්නේ දැන් force එක මෙහෙට මෙයා මෙහෙට මේව කරනකොට මේක මෙහෙට මෙහෙම උඩට force එකක් දෙනවා. Then the left side movement acts on the object. Therefore, object try to tend other side. Then it move to this side. Okay. Then අපි හිතමු අනිත් පැත්තට ආවා කියලා. Okay. Now the object like this. When come to other side, now again you can see buoyancy force moves to left side, and by that force it creates left side movement. මෙහෙම වම් පැත්තෙන් දකුණු පැත්තට movement එක නැත්නම් වාමාවර්ත කූර්ණයක් ඇති කරනවා. එතකොට object එක මොකද වෙන්නේ? අනිත් පැත්තට යනවා. Likewise, object oscillate about the axis, okay, about the axis without change their stability. Okay, මේක ඇත්තටම මෙහෙම වෙනකොට දෙපැත්තට වෙනවා කියන්නේ යාගේ කිසිම ඒ කියන්නේ පෙරලෙන්නේ එහෙම මොකුත් වෙන්නේ නැහැ. යා මේ stable වෙන්න පුළුවන්. stable වෙලා ඉන්න. Okay, Okay. In tilt position of the body of the buoyancy force acts in a vertical upward direction at B1. Okay, here B dash. Okay, B dash. Now, if a vertical line is drawn through the new center of buoyancy B dash. Okay, sorry, B1, B dash. It intersect the axis of the body BG at the point M, which is known as metacenter. Okay, this is known as metacenter. Metacenter may be defined as the point of intersects between the axis of the floating body passed to the point BG and the vertical line passed to a new center of the buoyancy force. Okay, now this is the new buoyancy point. Now if you write the vertical line, then it's intersect this point at the metacenter. අපි මෙහෙම BG line එකක් අදිනවා මෙන්න මේකේ buoyancy force එක line එකක් අදිනවා එතකොට මේ දෙක intersect වෙන තැන අපිට meta center line එක හොයාගන්න පුළුවන්. Okay, the distance between the center of gravity G and the meta center M of the floating object is known as the metacentric height. That means GM. Okay, GM, MG, GM. Okay, then we can define the GM equal I divided by V minus BG. Okay, first BG, what is BG? The distance between center of buoyancy and the center of gravity. What is psi? I is the moment of the inertia about the axis. Which axis? Okay, that is very important. Now you think I will take a boat. Okay, now you think that this is the boat, the front shape. This is the front shape, and this is the right side, side place shape. මේක මෙහෙම නෙවෙන්නේ එන්නේ එතකොට කමන්න. අපි මේ බෝට්ටුව එක මේ ඉදිරි පැත්තයි මේක බෝට්ටුවේ. Now I think this is the boat. Okay, now this side is front side, this is side view, this is the front view. Okay, now the boat is oscillating about which axis? About the axis, this axis or this axis. I will take the top plane. I will take top plane here. I will draw a top plane here. ඔයාලට තේරුම් ගන්න මම top plane එක අදින්න. එතකොට දරුවෝ මේ object එක oscillate වෙන්න පුළුවන් axis දෙකක් තියෙනවා. There are two axes. This is one axis is here, the other axis is here. Now normally object will be oscillating about which axis? This axis. Okay, axis through here, axis through here. මෙන්න මේක axis through here. Therefore you want to take the moment of inertia of this shape, not this shape or this shape. About this axis, the cross section of the body. I should be take in the body when now you think the oscillate plane. Okay, දැන් මෙහෙම ඔබ්ජෙක්ට් එකේ මේක ගත්ත මේ ක්‍රොස් සෙක්ෂන් එක ගත්තොත් මේ ක්‍රොස් සෙක්ෂන් එක තමයි මොනවා වෙන්නේ මෙහෙම ඔසිලේට් වෙන්නේ. අන්න එහෙම ඔසිලේට් වෙන මේ ක්‍රොස් සෙක්ෂන් එක තමයි අපි ගන්න මොකක් විදියටද? I හොයන්න ගන්න. Okay, we won't take it to find the I. BG, volume, submerged or displaced water by the water when it is at equilibrium position, not this position, in the equilibrium position. Okay, normally it is equal to, okay, we will go through some example, then we will try to find the, before that you want to know how to find the I. Okay, you don't want to find it, there are some definition. The rectangle This is G, the center of gravity, and this is the rectangle. Okay, now this is the area, moment of inertia about axis C, CG. Okay, about this axis here, this axis. Okay, moment of inertia. Now we don't want to take this one. Okay, we want to consider this one. It is enough to take only this part. Okay, it is enough to take only this part because we don't want IO. IO means the shape above the top plane. Top plane what? Front plane again, top plane what? Okay. Now you want to take the side front face to find your moment of inertia. Just if you know the length and width, then you can find the area and BA. You don't want to know how to do it. In the railway, you have learned it. If it is triangle, you can use this equation. Okay. Now, or circle or trapezium, you can use this equation. Okay. Okay. The stability of submerged and floating bodies. Now we can define the stability of the submerged body based on the metacenter. Okay, there are now normally there are three types of equilibrium. There are three types of equilibrium. There are three types of equilibrium. The stable equilibrium, unstable equilibrium, natural, or neutral equilibrium. Okay. First, stable equilibrium. Okay, before that, I will take some example to understand this. Okay, with the solid body. Now you think there's a plane like this and plane like this. Okay, I will take a new slide. Okay, here you think there's a horizontal plane, there's some curve like this, then the curve like this. Okay, now you can, now there are three objects, initially three objects like this. Here one object is here, another object is here. Now you give small displacement. If you give small displacement of the object, okay, this is A, this object number A. Okay, object A. This is object B. This is object C. This object is called C. Now, if you give a small displacement of the object B, what happens? After a while, it's oscillate about this axis and finally takes its original position. Okay. After, if you give small displacement and it takes its original position after a while, we tell this equilibrium called as stable equilibrium. Okay. Now here, now if you give small displacement here, they remove free your object, then it doesn't come to its original position. That's a equilibrium called as neutral equilibrium. What happens if you give small displacement here? Okay, it doesn't come to its original position, and it is not possible to come its original position. Okay, that's called unstable. මේක අපි ආරම්භ ස්ථානට යනවා නම් ස්ටේබල් ඉක්විලිබියම් කියන මේක අපි ගිහිලා තැනක තිබ්බොත් ආය මූව් වෙන්නේ නැහැ මුකුත් වෙන්නේ නැහැ. ඒක නියුට්‍රල් ඉක්විලිබියම්. මේක මූව් වෙනවා. හැබැයි කවදාවත් ආය ඉන්න තැනට එන්නේ නැහැ. Okay, it is called as a unstable equilibrium. Okay. Okay. Now in the floating body, if the point M is above G, the floating object will be in stable equilibrium. If unstable equilibrium, if point M is below, in between M and Z, B and G, the floating will be, or below the G, the floating object will be in unstable equilibrium. If the point M is at the center of gravity, that means G of the body, the floating object will be in natural equilibrium. Okay, give me 1 second. There's some problem. Okay, now this is the original question. If you give a small displacement, if object rotates about this axis, okay, this is the metacenter. That means the object oscillates about this axis. Okay, now G is here and B is here. Now you can see there's some distance between G and B, and by this distance, it can make some movement on the opposite side of the moment. Make a moment එක මේ පැත්තට තියෙන B ගේ moment එක අනිත් පැත්තට දෙන්න පුළුවන්. ඒක නේ stable වෙන්න පුළුවන්. But here you can see G is here and B is here. Okay, this is the metacenter. The metacenter is vertical to buoyancy point. That means G is now here. There's some this now by this B, it gives the movement in this way, this direction, and also object moves that direction, rotate that direction. එතකොට මේ object එක මෙහෙම කැරකෙන්න පුළුවන්. ඇයි මේක අපි මේ පැත්තට දෙනවා, B ගේ moment එකත් මේ පැත්තට දෙනවා. එතකොට මේ object එක කැරකිලා original position එකට එන්නේ නැහැ. Okay. Okay. In this also, that's now the stability of the floating, this metacenter is called floating. Okay. Now here also, if it is stable, if M is above the G, if M is below the G, this system is unstable. If M is exact to G, on the G, then that is stable equilibrium is called as neutral equilibrium. Okay. Now that's all the theory. Okay. Now here we want to know the basically what is buoyant force, buoyancy force, the center of buoyancy, and the metacentric point, metacenter. Okay, metacenter. Now, and you want to know how to calculate the metacentric height. It is I over BG minus BG, and this metacentric height GM. Okay, GM may be plus or minus. If it is plus, that means the metacentric metacenter it is above the G. Above the G. That means if metacentric height is positive value, the system is stable. That means stable equilibrium. Object is stable equilibrium. But if GM is minus, that means the M is below the G and the equilibrium of the system is unstable, or object is unstable equilibrium. May GM tenage danana system is stable, GM tenage rinana system is unstable. Based on this calculation, we can find the metacentric, we can find the stability of the object. Okay, now we will go through some example. Okay, now this is the example number 1. Okay, now let's go to example. I will share the screen. Okay, now we will go to, okay, we will go to example number 1. Okay, this is example number 1. This is a pontoon. Okay, this is kind of some kind of boat. Okay, now in this example, there is a rectangular pontoon and the length is 3 and width is 3 and the height is 1.2. The depth of immersion of the pontoon is 0.8 in seawater. Now center of gravity is 0.6 above the board of the pontoon. Determine the metacentric height. The density of seawater is this value. Okay, please now you can first find. Okay, first find what you want to find. First you want to find the metacentric height. Okay, let's go what we want to find. Okay, first you want to find the metacentric height GM, then you want to find the I and the V and the BG. Okay, first find the I. To find the I, this is the rectangle, therefore you can use this equation. Then this is the V. To find the V, what can you use? You can use this relationship. This relationship. Okay. Then find the B. You know G. Okay. Then finally you can calculate it. It is very easy. Okay. Based on this equation, what is it? Sorry. Metacentric height. Metacentric height is equal GM I over V minus BG. Okay. Let's go to find out the answer. Okay. Example 1. Okay. There's a rectangle pontoon. This is the object which is oscillate about this axis. This is the front view and this is the side view. It is 5 meter long, 3 meter weight with 3 meter wide and 1.2 height. This is the boat, therefore it is the center of gravity is, and is given here. This is the G. Okay, this is the G. This height is 0.6. But first, what you want to find? The I. To find I, you can use I square what? Moment of inertia about the center of CG, center of gravity. It is B D3 divided by 12. Okay, what is B? It is the width of the object. It is 3. The height is D. D is equal 6.3 to the power 3 divided by 12. Now you can find the moment of inertia I. Okay, moment of inertia I. How we find? We try to find 6.3 to the power 3. Okay. Multiply by 3 divided by 12. Then the answer is 0.045. The unit is m to the power 4 because this is the length and this is the length. Normally we take kg m to the power 2. Here we take this much. Okay. You can write down. What? Now we know this is 0.045. Then we want to find the V. To find that one, we can use Archimedes law. Okay. Now we can use Archimedes. Okay. Using it is equal, U is equal P rho G. For equilibrium, we can say U should equal mg. Then we can write down 0.65 1.2. Okay. Then we can say V rho G equal mg. Okay. Now my main point is to find this one. This is cut, and the V we don't know. Density should be given. Oh. Okay. We want this one also. Okay. The weight of the pontoon is 2,500 Newton. Okay, here. Okay, we'll keep the G here. And rho is 1025 multiplied by 9.81. This is sequence. This is 200 Newton multiplied by 9.81. No, sorry. Mg is equal what? Mg is equal 2000, 5,100. Now, we're going to find the I. Then I is equal what? Sorry, V. V is equal 2,400 plus divided by 0.25 divided by 9.85. This equal 0.248 minus, sorry, m to the power 3 V. Okay. Now what we want to find? Now we know the displacement volume. This is the displacement volume. Now you think, now this is the board. Okay. You think like this. Okay. Now you want to find the center of buoyancy. Okay. This is the object. Now first you want to find the immersed submerged volume. It is 0.25. How do you calculate it? The length is 5, width is 3, then this the height is x. You want to find this x. Clear? Now if you find x, the metacentric or this b, or this can be found by dividing this x. Okay, then you can find this height. You think this side is equal x, the total height is equal 2x. Okay, I will draw a figure like this. This is the B, this is the J, this is the P. Okay, this height is x. Okay, this total height is 2x. We don't know කොහෙන්ද මේක මේ වෙලා තියෙන්නේ කියලා අපි දන්නේ නැහැ. ඔහොම අද ගන්න පුළුවන්. පැහැදිලිද දන්නේ නැහැ කිව්වේ. මේකේ මේ මොකද්ද මේ ගිල්ලා තියෙන එක ප්‍රමාණය පරිමාවේ මැදින් තමයි තියෙන්න ඕනේ මොකද්ද? මෙන්න මේ x ප්‍රමාණය. Now I am going to find x. How do you find x? Now we can say and b equal 5 3 2x. Then this is 0.248 multiplied by 50 30 x. Then you can find x is equal 0.248 divided by 30. It is equal 0.008 meter. I think it is better to take the higher value for this one. Okay, take this one as 1000. Then this one is take as 0.992. Okay, here 0.992 divided by 30. You can take this as 0.3. Okay, meter. Okay. Okay, now we know x. Now I will draw a picture with all data. Okay, now 2x, what is 2x? It is equal 0.066. Now this height is 0.066. This is the B and this is the G, and this is equal 0.6. Okay, now you want to find the BG. BG is equal what? This height minus this height. It is 0.033. Then final answer 0.5771. Okay, meter. Okay, and then we know BG. We know this is 0.992. Okay. Finally, we can find metacentric height GM equal I over V minus BG. I is equal 0.0454 divided by 0.442 minus BG 0.567. Then the answer is minus 0.57 meter. GM is less than 0, therefore it is unstable. It is unstable. We can say it is unstable. because this is minus value. Let's go to example number 2. This is 1000. 10,000. A block of wood of specific gravity floats in water. Determine the metacentric height of the block if it is size to 1.8. Okay, first it is better if you find the density of water. Density of water is 1000. Density of 1000 water. Okay, first Sg, it is equal rho divided by rho water, and this is 0.75. This is rho divided by rho water is 1000. Therefore, the density of object is 750. Then rho is equal 750. Okay. Now we can calculate the weight of the object. Okay. Weight. Oh no, we don't want to find the weight of the object. Okay, we can use now what we want to find: metacentric height, the I. This is the wooden block. Okay, the wooden block. We want to know the height and width, not the length. Normally, okay, normally in 2m, 1m, and 0.m. Here, this is the length, this is the width, and this is the height. If you find the dimensions like this, it means the first one is length, the second one is width, and third one is height. Okay. Here, width is 1, height is 0.8. Okay. You want to find the metacentric, sorry, I is equal BD 3/12. Okay. What is B? B is the 1. B is 1, D is 0.8 to the power 3 divided by 12. Okay. 0.8 multiplied by 0.8 multiplied by 0.8 divided by 12. The answer is 0.0427. Okay. Meter to power 4. Now we know the I. I will note down it. I is equal 0.0427. Now what we want to find? Then we want to find the displaced water volume. To find it, you can use Archimedes law. Using Archimedes law, U is equal to V rho G. For equilibrium, you can say U is equal to mg. Therefore, you can say V rho G is equal mg. Okay. Now you want to find the V. Okay. Now we know V is VD, don't know V. Rho is 1000. We can cut G. Then M. Rho is equal M over V. Then M is equal rho V. The density of object is what? Density of object is okay. Now you think, now this is the block. This is a block, therefore you can use this one directly. උනට බෝඩ් එක එහෙම යන්න බෑ මොකද හැමතැනම පරිමාව සමාන වුණාට ඒ හැම පරිමාව ස්කන්ධයක් නැහැ. Okay, here rho is 75. The width, the volume 2108. Okay, V rho V. M is equal rho V. Okay, now what can you find? The V is equal 75 multiplied by 0.8 divided by 1000. It is equal 1.2 cubic meter. The V is equal 1.2 cubic meter. Then what we want to find? Now, this is the object. Okay. Now, G is here. It is, what is height? 0.4 meter. Then you want to find, this is the underwater volume, and this is the B, this is dx, 2x, and this is x. You want to find x, then you can find the difference between BG. Okay, BG. So you know V is equal what? Is equal this length, sorry, with this length is equal to, width is equal 1, and the height, underwater height is 2x. This is 1.2, 2 by 2 multiply x. Then you can take x as 0.3 meter. Now this is 0.x. This is 0.3. Okay. Therefore, you can say BG is equal what? 0.4 minus 0.3. It is equal 1.1 meter. Okay. Now you know the BG. Now you can say GA is equal I over B. BG. What is I? It is equal 0.0427 divided by V 1.2 minus 0.1. 0.0427 divided by 1.2. Okay, minus 0.1. Now GM is equal minus 0.0644. That means it's below the okay. Now this is B, sorry, this is G, this is B. If M is plus, it is in this above the G. If GM is minus, that means the metacenter is here. This this height is 0.0644. That means this is in the, therefore the block is in unstable equilibrium. Unstable equilibrium. You can say like this.